Hi everyone, this is Introduction to Python, first lecture for CSC 232. We're going to start with what is a computer? A computer is a programmable general purpose machine made up of the CPU, memory or RAM, and then different input-output devices or I/O devices like a keyboard, a monitor, speaker, and they're all connected by the data bus here. It's a general purpose machine, so that means that it can be used for anything you want as long as you can write a program to do that task. Since there's a huge gap between our high-level programming languages and the machine code, we need a program to bridge over the gap. So that's a compiler or an interpreter here. Programs written in some languages, such as C or C++, are compiled straight into machine code, all these ones and zeros, by a compiler. But programs written in other languages are compiled into intermediary code like assembly, which is then compiled into machine code later. Programs written in Python need to be translated into machine code by an interpreter. So that's a slightly different process. The takeaway from this slide is that programs you write in Python are then translated into machine code. Otherwise, you cannot execute your programs on a machine. So what is Python? Python is the language you're going to be learning in this course, and it is a high-level programming language created by Guido van Rossum, a Dutch computer scientist. And programs written in Python are executed by the Python interpreter. They're just text files that are interpreted by the interpreter and executed on the machine. So you've got your source code in a text file, goes through the interpreter, and then you view the output on your screen. So what goes into one of these program files? You have program code, comments, and white spaces. So program code is expressions, statements, and definitions, and we'll go into the difference between these on the next set of slides. Comments are code that's not interpreted by the machine. It's only for other developers or for yourself to familiarize yourself with what's going on with the code. So any text after this pound sign or hashtag is considered a comment. And then white spaces. White spaces are very important in Python. They separate tokens, so like different words or spaces around an equal sign. And indentations with white space also indicate the start and end of a block of code. So how many levels indented you are indicates some information that we'll go into later. So expressions, the first element of program code. In addition to a value, an expression can be a combination of values, variables, and operators. So all of these are expressions. 3 plus 2, any operators you're going to do to it. You could combine multiples of these. Multiple expressions combined together are still just an expression. Every expression evaluates to a value at runtime, and every value is represented as an object in Python. In other words, a value is an object in Python. So an object is a piece of data created and maintained in memory by a Python interpreter. And in this course, I'm going to use value and object interchangeably. Every value has a type. So to be more precise, every object has a type. Type is important because it determines how the value can be processed. So for example, if two values are numeric values, you can apply arithmetic operations to them. You can add them or multiply them, but you can't add a numeric value to a string of characters. So 1 plus, the string 2 doesn't really make sense in Python. These are the available data types in Python. We've got integers, floating point numbers, strings, booleans, and a none type. So an integer or an int is a whole number. Numbers with fractional parts are called floating point numbers, and that type is a float in Python. And then strings or str is a string of characters, any string of characters, and its type is a str in Python. True or false are Boolean values, and the type is called a bool in Python. Only 2 options for that. And there's also a special value called none, which represents the absence of defined value in Python. So its type is none type. The order of arithmetic operations is the same as math. So PEMDAS, which you all remember from algebra way back in the day. and operators with the same precedence are evaluated left to right. So this 1 plus 2 times 3 minus 4 is evaluated as 2 times 3 or 6, plus 1 minus 4, so 3. And this is evaluated to the same thing. When you add some parentheses and change the order of operations, this is now going to evaluate to negative 3. 1 plus 2 is 3 times negative 1, negative 3. 3 times negative 1, also negative 3. Then there's also comparison operators. So a comparison operator compares two objects and evaluates to a Boolean value, true or false, which is the bool type. So using comparison operators, you can create a Boolean expression. To check equality between two objects, right here you have the double equal sign. It's a double equal sign because the single equal sign is assignment, so like which we'll get into in the next set of slides. So 1 equals 1, this will be true because they have the same value. Not equal, exclamation mark equal, checks for inequality. 1 is not equal to 2, this will also evaluate to true because 1 does not equal 2. This one right here, next one down, is the less than sign, and there's also the less than or equal to. So 1 less than 2 evaluates to true, and 1 less than or equal to 1 would also evaluate to true because it can be equal as well. This last one is greater than or equal to. 5 is greater than 3, that also evaluates to true, and 5 greater than or equal to 3 would also evaluate to true. Comparison operators. So to compare two objects with the comparison operator, the operators from the previous slide, the objects have to be the same type or they must be comparable by the operator. So two numerical type objects like an int and a float can be compared to each other with any comparison operator. You could also check for equality between an int value and a string or a Boolean value, but you can't check if an int value is smaller than a string. That will give you an error. So 1 is equal to true, that's 1 is equal to 1, that's going to be true. 1 is equal to 1.0 in Python, that evaluates to true. 1 is not equal to 1.1, that's also true. 2 is greater than 2 to the 0.5 power, or square root of 2, that's true. 1 is equal to the string 1, that's false. Now that's a common gotcha in Python, because the types are not always immediately obvious. And so 1 looks like it should be equal to the string 1, but they don't evaluate to the same thing. 1 is equal to true, that's true. In Python, there's this concept of truthy versus falsy values. So the number 0 is false and any other number is true. And so you see this last one, 0 is equal to true, that's going to evaluate to false. And here we denoted what it evaluates to with the comment. That's common in computer science. If you take two objects that are not comparable with this operator, remember you can't use the less than operator for strings. Strings and numbers being compared together. 1 is less than string 2, you get a type error. Statements. A statement is a unit of code that the Python interpreter can execute. So some examples would be the assignment x equals 1 or y equals hello. So an assignment assigning a value to a variable is in a statement. Now going into what assignment is, an equal sign is a single equals is the assignment operator. We sort of alluded to that earlier. It takes the form of variable equals expression. So it assigns the value on the right-hand side to the variable. So x equals 1 would be variable is x, expression is 1, so the statement x equals 1. And to fully understand that, we have to go into what is a variable. A variable is an alias or a label for a value or object. It's for storing an object so that the object can be referenced by some convenient and meaningful name later. Variables must be defined before being used. That means that a variable has to be created before you can use it. If you think of variables like a box you can put anything in. If you don't create the box first, there's no way that you can then later check what is in the box or update what's in the box. So in Python, an assignment creates a variable. In this case, we have x equals y plus z, which assigns the result of y plus z into x. And that is going to fail because y plus z have not been defined yet, or y or z have not been defined yet. Little aside here, the code on the right-hand side of the equal sign, so the expression will always be evaluated before the assignment happens. So you'll see on this slide, if we then run it like this, y equals 1, z equals 2, and then x equals y plus z, we can see the variable here, y, in its box has 1, z in that box has 2, and then x equals y plus z will get the value of 3. If you were to then change y later to say 5, x would not be updated because the assignment evaluates the expression and then gives the result to x. A bit of nuance that we'll definitely get into later. So variable names, what can you call these different things? It can be alphabetic letters, numbers, and the underscore character, but it cannot start with numbers. So the variables name, val1, underscore var, student at Cal Poly are all legal, and 123 student at Cal Poly with the @ sign or %12 are illegal variable names. Common casing in Python is to use underscores to separate your words. So it would be student underscore at underscore Cal underscore Poly. It makes them more readable and you don't have capital letters. So useful operators for updating the values of variables. Even if all you could do with the variable is assign something to it and then reference it later, that would still be useful. But since you can actually change the values of these things, you can keep counts, you can do all sorts of interesting stuff. So we have addition. So first we create the variable, var equals 1, and then these next two lines do the same thing. Variable equals var plus 1 and plus equals 1. This plus equals is just a shorthand for the above. And then subtraction, we have var equals var minus 1 and var minus equals 1. So you can see subtraction is illustrated by this diagram on the right. We've got var and it currently points to 1. And then after either of these operations, the value has been updated to be 1 minus 1, so 0. We've also got a multiplication operation. So variable equals var times 2 or var times equals 2. Again, they do the same thing. You can do any operator before the equal sign. So you've got 1 times 2 is going to be equal to 2. You can see the box is updated. There's also division, same as before. When you divide two integers in Python, you get a floating point number if that's the result. So in this case, 1 divided by 2 doesn't divide evenly. 1's not divisible by 2, so you get 0.5. There's also integer division. Integer division is going to floor it. So it will take the smallest, like the smaller whole number. If you've got 1 integer divided by 2, that will round down to 0. So it always rounds down. -1 divided by 2 will be -1, integer divided. Because it will have -0. This will evaluate to 0.5, and then it'll floor that down, and 0.5 rounds down to -1. So some exercises. Define variables x and y initially bound to 1 and 2. And we can go over these in class as well. And then the last exercise, switch the first and the last digits of the number 1,234. There are tons of different ways to do this, and I'm interested to see which ones you all come up with. Awesome, that concludes the first lecture. Thank you all for watching it, and I'll see you in class on Wednesday.